So previously, when you've looked at data, it was always two-dimensional. So you have seen this coordinate system many times, where you have two coordinates, x and y, to describe every point in a plane. For example, if you wanted to describe this point over here, you would see that it is 1, 2, 3, 4 on the x-axis and 1 up. So this point is actually 4, 1. And similarly, we would, for example, have over here the point 2, 2. But sometimes in many applications, two-dimensional space is not enough. If you just look around, you see our space that we live in is three-dimensional. So we would like to introduce a third dimension, and this third dimension is then called Z. When you introduce a third dimension, you actually have two choices. You can either draw it like this, or alternatively, you can also draw it like this. And if you start twisting and turning it, you can see that you can't transform this coordinate system into this coordinate system just by twisting and turning. You would actually have to use a mirroring action. And these two coordinate systems, they are therefore called differently. This one over here, this is called right-handed. And this one over here is called left-handed. And the convention that we're going to use is that we are never ever going to use left-handed coordinate systems. We're always going to use right-handed ones. Now, why is this one called right-handed? It's called right-handed because of the so-called right-hand rule. Actually, there are multiple right-hand rules. We'll see another one, I hope, soon. And the right-hand rule is called like this because of, well, the right hand. The mnemonic is the following. Imagine you are taking your right hand and hold the z-axis in your hand with your thumb pointing in the direction of the z-axis. When you then curl your fingers have this natural twist in them that you can also see down here. And this twist, this rotation, is the rotation that transforms the x-axis into the y-axis. So if we draw it like this, we would then draw x in this direction and y in this direction. Now, it might not be totally immediate that this one is the same as this one, but it actually follows when you just start turning it. So when you turn it around, you can actually see that these two coordinate systems are really the same, it just looks a bit ugly. Because of the right-hand rule